Hello everyone, welcome. Thank you for joining us. Whether you're new or a returning guest, great to have you here. I might sound a little bit different tonight. I probably should address that up front. So if you listen to our last stream, I might have sounded a little congested. And since that time, I really got to the end of the stream and essentially completely ran out of gas. So if I sound different, it's because I've been battling something. And I think I'm winning. But one of the effects is it's really taken me from a baritone down to a bass. So there's going to be a prediction market here, which is whether or not I can retain my voice that you can wager on. I shouldn't say wager, but you can purchase contracts on our favorite website, callshe.com. And I think we're going to lean into it. So I kind of like it. I think I might just continue to talk in this really deep voice and just make this part of how we do this. But I don't know if I'm going to be able to maintain that. So it's the sad part about feeling better that I'm probably going to lose that. So thank you for joining us. Good to see everybody. Course reminders. We have a chapter soft deadline today. So for all of our string algorithm stuff, both the following along with our code alongs and checking your work, as well as making sure that you can do the practice exercises. If you don't have those in, that's okay, but we do have a soft deadline to kind of keep you on the treadmill for that. That's today. A couple other things. First off, we're going to have a little bit more information. I think I've mentioned this, but we're going to have a little more information because it sounds like there's quite a bit of interest in completing a project. So that's great. We're putting all this together. I'm excited about it. I think it's going to be excellent. If you want to do a capstone project, we're going to have that option. And that'll be something that we're going to roll out for our Philomath members. We also have a new development that will be coming soon. And I mentioned this in the email for today. So if you're not getting emails from me, make sure to go to programmingforlovers.com, or you can join our mailing list that we have as in the description to this video, and you can get information. You know, we send information about our streams and everything else that's going on with our project, as well as additional courses that we're going to be launching. So check out all that on our mailing list. But I mailed out the information that we're going to be putting together an ebook accompanying Programming for Lovers, which is exciting. I'm really happy about that. And we're going to be sending that out to our Philomath members at some point in the next few days. So we're working on getting that together. As soon as it's ready, we'll be sending that around to you if you're already a subscriber. And we'll get that over to you as soon as it's done. If you're not a subscriber, you can always join us. I'm just going to drop a link in the chat. Our homepage on Memberful is linked in the chat now. So our subscribers will get that, or our members, I should say, will get that first off. And then hopefully at some point we'll have that somewhere else too, like on Amazon or something like that. But members will get that immediately. Tonight, we're going to be doing some drawing in Python, which is cool. We're going to start with drawing a snowman. And it's really an opportunity for me to demonstrate my extreme artistic prowess here. But we're going to get a very brief taste of object-oriented programming as we go through this. So that's nice because this is not a chapter that's focusing on object-oriented programming, but we're going to have an opportunity to kind of just get the briefest introduction to it. So if you haven't done object-oriented programming before, don't feel intimidated by this because what we're going to do is just very superficial. And it's really the point at which, when we make this transition to object-oriented programming, in the next part of the course, in the next chapter, that's when we can really start doing some powerful stuff. And we're going to see that to draw, we need to think about, like, we're drawing on? We're drawing on like a virtual canvas. And so having this ability to think of the canvas as an object is going to be really helpful. And so that's what we're going to see today. And we're also going to see that drawing means we need to work with a little bit more math. So there's going to be geometry that we need to think about, a little bit of algebra, and all that stuff is always going to be important. Graphics is a great example of how even some pretty straightforward geometry and algebra is important to consider when we're doing this. And then we're going to make a transition towards game of life. So at the end of today's code along, we're going to be able to draw a game of life board. And then when we've done that, that's going to prepare us for implementing Cellular Automata next week. So as we move towards our next two streams, the idea is we're going to be ready to implement the game of life, visualize it because of what we do tonight, and then implement an arbitrary cellular automaton and move beyond just this game of life, which I love, don't get me wrong, but we're going to be able to implement basically any cellular automaton. And that'll prepare you for the practice exercises for this chapter. That's everything associated with getting ready for today. That's where, should set us up pretty well. I think we're ready to start. As always, make sure to like and subscribe. If you're here live, I love seeing everybody in the chat. That's always the best part of this. And if you're not following us live, feel free to drop us a comment. But in the meantime, I think we're ready to go. So let's code. To get started, you'll see that I have a little bit of starter code here for us. And I have created a file, or a folder I should say, called drawing. And I have a main.py file within that with just a little bit of starter code here. The only thing that is new is that I have imported Pygame at the top, which is what we're going to use as the built-in module to allow us to, I should say, graphics library is what I should call it. And it's a built-in Python library. Of course, we're going to need to install it with pip. So that's the first thing that I probably should do. So the first thing I'm going to do is bring up a terminal. And if you don't have Pygame installed already, you can do so by typing on a Mac or a Linux machine. You can type pip3. On a Windows machine, you probably want to type pip. And then you can type install and then Pygame. And once you've done that, it should just go through this, and I might have a error, failed wheel build for install. Oh, good. Good to know that I failed this. I thought I had installed it already. But we'll see what happens here. I think it should be okay, but in the meantime, we have, once you've got that installed, then everything behind the scenes is ready to do some drawing. Now, to really kind of understand what we need to do, there are a few things that we need to understand what we're working with. So what is Pygame going to give us? And then how is it that we're going to, what is it we need to know about, like colors? And the first thing that I want to show you is how colors are represented behind the scenes. So behind the scenes, every color is represented by 3 numbers. And the reason why is because colors can be represented by a mixture of primary colors. And you may have learned about one way of representing mixtures of primary colors when we looked at paint. But on computers, everything is created based off of a mixture of light. And so the primary colors of light are different from what they are when we look at painting. They're red, green, and blue. And if you mix all 3 together, if you mix primary colors of paints together, you get black because you're subtracting out color. Whereas with light, you're adding color in. So when you add everything together, you get pure white light. So as a result, if you have no amount of red, green, or blue added, you get black. And so each quantity of red, green, and blue is represented by numbers between 0 and 255. And if you stick around for long enough in our class, you'll get to see why the numbers are represented in this range of 0 to 255, like what's special about 255. But for now, I'll point out, you can sort of pick your favorite color as we go. I said black is the absence of any light, so it's 0, 0, 0. White is the maximal amount of red, green, and blue all mixed together, so that's 255, 255, 255. You'll notice if you have equal amounts of red, green, and blue, you're going to wind up somewhere on the gray scale. So the maximum is going to be white, the minimum is going to be black. But if you say 128, 128, 128, then you're going to be halfway between white and black. So you're going to have a gray color there. Then like a pure red color is 255 red. A pure green is 255 for the green channel. And the blue channel is the third channel. So that's 255. If you want a duskier red, green, or blue, then in that particular case, you would only turn on each of those channels at like 50%. So 128 for those values would give you these duskier values. And then you can mix the colors in different proportions and you can get all different colors over here. So each row of this table corresponds to showing you the color and then the amount of light for each channel that you need in order to mix it together. So this yellow color is quite bright because it's a mixture of colors, but they're close to the maximal values. So you have 255 and 204. And you see that in these sort of pastel colors too, because there are large values over here. So the brighter colors are going to have larger values of your RGBs, and the duskier colors are going to have lower values over here. So you start to see these like earth tones down here when you have 51, 51, 153, and these sorts of things, because you have smaller values. And that makes sense because you're not turning on the lights quite as much. All right. I'll also say, to come back to main, one thing I will show you is every pixel on your screen, so whatever screen you're watching this on, it's probably a rectangle, but it's definitely broken down into small pieces called pixels that are rectangular units. And each of those pixels receives one and only one color. So graphics on a computer essentially are pointillism because we apply one dot of a single color to every location on the screen. But when we do that for a high enough resolution screen, we start to see patterns. And there's a built-in application on Mac in utilities called Digital Color Meter. And so what it allows you to do is to hover over somewhere. So wherever the mouse cursor is, it will tell you what the RGB values are. This is becoming very meta because I'm hovering it over itself. But if I look over here, you see that that's 28, 28, 28. So that's not quite black, which is 000, but it's a dark gray color. Looks like this might be, you see this is a slightly lighter gray. And so we're at 33, 33, 34. You also might hover over something like the N in name. And what you see is our eye can't quite zoom in enough to see this. But the way that this letter N is represented is actually not with completely solid colors. So you have one color that's 138, 191, 223, and you look one pixel over if I'm adept enough at moving the mouse. And that's 154, 214, 250, and then you have a grayer one that's 83, 109, 125. So this is what that N looks like if you could zoom in on it. But when we look at it, it looks like it's very highly resolved because you have enough pixels there devoted to it. So that's all, here's another color. 194, 134, 111 for this D in drawing, and then we have the yellow color here, which might be 216, 214, 165, and so forth. So behind the scenes, there's a lot of graphics going on that's assigning each individual pixel on your machine or on your display to one and only one color, and it sort of has these rectangles behind the scenes. So we want to use all this, and we want to use Pygame being built in. And what I would like to do is, in main, first off, initialize a Pygame session. So it's called Pygame. It's useful for when you're producing drawings related to video games that you might make. And I've imported Pygame, so I'm going to say, let's set pygame.init. And I should say what this does. This creates a Pygame session. The other thing we should do is establish a virtual object that we're going to draw on. And so just as if we were doing a real drawing, a real painting, I would get a canvas out, and it would be a blank canvas, and then we'd be able to paint on it whatever we wanted to. We're going to think about the same thing in terms of a virtual canvas that we're able to work with on the machine. And that virtual canvas is going to be rectangular, so that's good. So it's going to be a box. And the units here are going to be based in pixels. So one pixel is like what we mean by the width of one of those little squares that constitute the units on a display. And so let's make, for example, what we're gonna make is a canvas for drawing a snowman, and I'm gonna make it have width and height equal to 1,000 pixels across and 2,000 pixels tall. And I can actually declare two int variables like this together just by separating them with a comma. So this allows me to declare two integers with just one line of code, which is a nice feature. And then I want to make the canvas, and that's going to be an object that is width by height pixels. Okay. So in order to do that, I'm going to call this thing, I could call it canvas. I'm going to call it surface. And that's because behind the scenes in the Pygame library, there is a function called surface that takes the width and the height in pixels that we care about and produces a surface object from this. So this is our canvas that we're going to draw upon. And that's all you need to think about for now, is that there is a virtual canvas and it's blank, but it's 1,000 pixels wide and it's 2,000 pixels tall. There's one other critical thing though, which is a little bit, I don't know, Pythonic. And I need to make sure that I point it out because this is a natural thing to get stuck on. Pygame.surface doesn't take two integers. It takes a tuple as input. So you technically need to give it another set of parentheses. So width and height in parentheses is what's the input. It only takes one thing as input, which is the tuple. And so that looks a little strange. It's just because the input to the function, which is inside the yellow parentheses, is width and height, which is enclosed by the magenta, would we say, parentheses, in order to represent the width and the height as a tuple. Then the next thing that we might do is, while we're in tuple land, if I know that a color is represented as 3 integers, I'm going to define some color objects as tuples. So I'm going to create a color associated with black, and I remember, well, black is the absence of any light, and so it's going to be the tuple 0, 0, 0. White is going to be the opposite, so it's going to be the maximum amount of red, green, and blue light. And then we can create any other colors that we like. So you could go and consult an RGB table, color chart, and go find your favorite colors and declare them as much as you like. I'm going to have a very simple red, which is the maximum amount of the red channel, no green and no blue. So we've declared some colors. I should have said that I'm doing that. And you can declare any that you like. Be good practice. And then, much like the Rolling Stones, let's paint the canvas black to start off with. So I'm going to say we're going to set surface.fill black. And this is our first, well, I don't know if it's our first instance of seeing this, but it's pretty close to our first, which is that we have an object, and then we have this dot, and now we have a function associated with that object. So this is called a method. And when we work with object-oriented programming, you're going to become very comfortable with this. But for now, all I want you to think about is there is a function associated with the canvas that says fill the canvas with whatever color you give this function as input. A lot more on this will come later, so don't worry. And then one other thing I should do is let's save the image and then quit Pygame, which will, it's not like strictly required, but it will save memory. So we're going to say pygame.image.save and we're going to give it the surface that we created, and then we're going to give it what we want to call this, which is snowperson.png. And then we're going to quit. So we're going to call pygame.quit. Not quite quit. And so this is another example of a method. This looks like a method, but it's just that it's coming from the Pygame package behind the scenes. So we're calling Pygame, and then this is the built-in quit function. All right. Now we should run this. So I should save my code, and all I'm going to get is a black rectangle. But I'm in SRC, and I need to navigate into the directory that I just created. So drawing, and then I'm going to run my code with Python 3 on Windows or on Mac, or Python on Windows, and then main.py. And I see my black rectangle get created. Not very thrilling thus far, but at least it's something. And now we've got our blank canvas that we can draw upon. All right. I've got my emergency cough drop supply here that I'm going to be accessing. You can purchase a contract on the over-under of these that I'm going to consume in one stream. Insider trading would say probably the over. All right. So I can draw my rectangle. Here's our canvas. There's something critical to know. So we've seen RGB coordinates, RGB values that represent a color. So a color is represented mathematically as like 3 numbers. There's something we also should know, which is that regardless of what computer you're on, regardless of what programming language that you're using, we all agree on how to represent the coordinates of something in this rectangle. So if I need to draw something, I need to tell the language where on the rectangle to draw it. But then we need to know, well, what do the coordinates mean? And so I will show you your math teachers and all the math people brainwash you into thinking about a coordinate system in the Cartesian fashion. So the origin, or 0, 0, is down here in the bottom left. X increases to the right, and Y increases upward. So a value like 300, 100 means go over 300 units, go up 100 units. 50, 200 means go over 50 units, go up 200 units. In graphics land, and this goes back decades, the coordinate system that we use is completely different. The origin is not in the bottom left. The origin is in the top left of your screen, whatever that is. So for our rectangle, we're thinking about the rectangle as like a little mini screen. So the origin of the rectangle is going to be in the top left. We're going to have, still the x-axis is the horizontal axis, so far so good. X is going to increase to the right. But now you have to go down. So the y-axis is going to increase down instead of up. That will wind up being important for us to know when we start drawing things, so that we know, am I drawing something, with respect to other things, it's going to be at the top or the bottom. And in this way, for example, 300, 100 is 300 over, 100 down. 50, 200 is 50 over, 200 down. And that's a little bit annoying, as we're going to see, because it's intuitive, it makes sense. But it's a little annoying because we already have a way of representing two-dimensional things, which are arrays, right? And in arrays, I've had you think about, first we go down, and then we go over. So there's a little bit of a complication, because you'd say, well, the origin is still in the top left. That's right. That's a good thing. But notice that the rows are going down the y-axis, and we usually think of that as like the first index in a two-dimensional list. So the rows are going to be the y-axis, and the columns are going to be on the x-axis. And that needs to be something that's in the back of our minds, because we're eventually going to range over an array, because this is what, like, how cellular automata are going to be represented. And when we range over the array, we're thinking, oh, I range over the rows, and then I range over the columns. So board of 1, 2. Is it row 1, column 2? That actually means you need to go over 2 first, and then down 1. So they're similar, but they're not quite the same. Now, with this in mind, that the graphics coordinate system goes over and then down, what we'd like to do is add a little bit to our drawing. And what's nice is that the Pygame library is going to include a lot of built-in functions for drawing. So when I go to main, what I want to do is, right after I've filled the canvas, I want to call a function called draw snowperson. I mean, I could put this in main, but I also want to make something that's pretty general. And I need to think about, what is this function like going to necessarily take as input? And so I'm going to go ahead and start typing out my draw snowperson function. And I'll add some type hints here too. And I'll need to have a doc string. And this is going to draw a snowperson to a given canvas. If I call the function, it should know which of these Pygame surfaces it has access to. So I need to give it, first and foremost, I need to give it the surface. So I need to tell it surface colon, and the type here is a Pygame dot surface object. Okay. So that's the first thing that we should take. And then I'm going to allow for my snowperson to be drawn with 3 colors. So the background here is going to be black, but I'm going to draw the snowperson on top of it. And what I need to then take is 3 colors associated with it. So in this particular case, I'm going to say, well, I'm going to give it white, black, and red. Those are the 3 colors that I've already introduced. Those 3 things are just tuples. So we're comfortable at this point seeing that these are tuples of length 3. And what are white, black, and red? What they're going to really represent, is like the body color, and then they're going to be like maybe a like the buttons that we're going to have, or the eyes. So we're going to call this maybe like the object color, and then we're going to have a third color that we're going to use for accent, where I'm just going to use it to draw the mouth. So all of these things are all tuples of 3 ints. So I'm going to add that after each of these things. And at the end of this process, I'm not actually going to return anything. So I'm going to say none. So I should say parameters are a surface object followed by 3 colors as 3 tuples that we will use to draw on this object. And then the output is none. And I could have some parameter checks here for sure. So I want to make sure that these tuples have the appropriate lengths and so forth. It's going to be a lot of checking. And so I'm just going to go ahead and say, for now, let's think about what we want to do. And I'm going to use some modularity. And for some modularity, if we think, well, I've got 3 balls associated with the snowperson. I've got the head, the body, and the bottom. I'm going to have a draw head function I'm going to have a draw middle function, and then I'm going to call draw bottom. And all of these should get passed in. So surface, comma, body color, comma, object color, comma, accent color. And so I'll give all these parameters as inputs to all of these. I'm also going to comment this out for now, because I want to just focus on drawing the head. A function that I've not written. Now it's an opportunity for us to write that function. So let's write the function to draw the head of the snowman. Now we can start really working with built-in stuff. And it'll give me a chance to ask you a question, because I haven't had a chance to ask you a question yet. And the first question I have, well, I'm going to say, draw a head. And I'm going to be lazy, and I'm going to take all of this stuff as input. And it's not going to return anything. And the doc string is going to be very similar. Okay, so in this particular case, we're going to draw the head of the snowperson. And the parameters are going to be the same. The output's not going to be anything. So if we're thinking about drawing this, the first thing I'm going to do is I'm going to paint a big white circle that corresponds to the head. And then here's my question for you. What defines a circle? And I know I'm asking you to jump into the Wayback Machine of your mathematics past. But what actually constitutes a circle? We're going actually all the way back to ancient Greece. Some good answers. One good answer is to think about cosine and sine are the x-coordinates of the circle. And that's true as you go around the circle. But I don't need to think necessarily about the x and y coordinates. Although if I'm actually going to go into the bowels of how Pygame is implemented, it might be a good idea for me to know this. But in my geometry past, I was positively brainwashed to think about what I see from a few folks, which is good. Think about the compass. If you used a compass in geometry class where you set it down to a point and then you draw the circle. And that's because you establish the center of the circle. And then you draw all of the points that are fixed distance from that center. So a center is defined by its a circle is defined by its center and radius. And we're going to keep that in mind. It's a very important point that we're going to come back to when we talk about object-oriented programming. Because a great way of getting at object-oriented programming is thinking about shapes and what information you need in order to represent a shape. Like I wanted to create PowerPoint or something, and I need to have shapes on the canvas somewhere. So if the circle is defined by its center and radius, what I'm going to do is I'm going to draw a circle on the canvas. So to do that, there's going to be all these built-in functions within Pygame, and especially pygame.draw. One of them is called a circle. And it needs to take the surface, and it needs to take the color that we care about, which in this particular case, you're thinking about it as white, but it's really the body color. And then what it needs to know is the center and the radius. So it takes them in that order. And all this makes sense. You know, I'm drawing something on the canvas. I need to know what color to make it. And if it's a circle, it needs to know the center and the radius. So as we continue to think about what functions need to know and what they return. Everything is about flows of inputs and outputs. This also is not going to output anything, but it needs to know these 4 things as input. And here's where I'm going to say, okay, remember that our canvas that I'm drawing upon is 1,000 pixels wide, 2,000 pixels tall. Also remember, top left is going to be the origin. You go over first, and then you go down. So if I want to go over, let's put the circle in the center. What does the x-coordinate need to be if I'm going halfway over? Good God, 500, okay? 500 is half of 1,000, so I'm going halfway over. That should be 500. Y should come down somewhat, but it shouldn't go down to 1,000. That would be bad. Then the head of the snow person is going to be in the middle of the canvas. We don't want that. So what I'm going to do is I'm going to drop it down 400 pixels. You can move this around. And one of the things I want to encourage you to do, please play around with this later if you want. I'll give you a way of doing that. But this is just an opportunity for us to mess around with Pygame so that we're comfortable in its low stakes when it comes time to do this for Game of Life. We need the radius too, though. The radius I'm going to give it is 180. So it would be bad if I made it 600, because then it's not going to fit on the canvas. And in fact, I could show you what happens when we do this. So I could save this. Let's make it too big. I could save this, and then I've got in main, I'm calling draw snow person. And that's going to call draw head. And I'm going to hit up and run it. And then I can take a look at snowperson.png. You see the head is way too big. So here's an opportunity for me to go back and say, all right, this is why I don't set it that large. I'm going to set the radius to something like 180. And when I save it now, and I run it, I'm going to see there's the head of our snow person. There's something that you could infer at this point in time, even though this is our first real foray into object-oriented programming. There's nevertheless something that you could tell me that you know about how objects are treated within Python. What am I getting at? What is this thing? What is this property that you might say that we know about with objects in Python? If you need a hint, let me know. My hint is that when we call our function, you fill the canvas, then you draw the snow person by passing in the surface to this function. But yet it's in main that you save the image using the surface, and then you quit. So you might say, well, one of the things that could happen is that when you pass surface into the function, a copy of this surface gets created. If that were the case, then when you call this function, nothing is returned. It's the copy that we edit, and then the copy dies, which is what we've seen for strings, integers, a lot of built-in types, and even tuples. But it's not what we've seen for lists or maps. And this is a glimpse into our object-oriented future, for us to already realize that objects are pass by reference. John got it, good job. But objects in Python are passed by reference. And technically, here's where the actually guy can show up and say technically, like everything in Python is an object, and everything in Python is pass by object reference. But for now, well, it's an object and it's pass by reference. We'll say more about that later. Let's add some facial features. Our snow person is not looking very lively. So within draw head, I should add some features. And the next thing that I might do is add a nose. And here's where we might look at our snow person and say, okay, well, the nose probably should be in the middle of the face. So the x coordinate is going to be 500. And let's make it like slightly below the center. So I'm thinking the y coordinates are going down. The center here was at pixels, the coordinate 400. So as I'm going down, I want to go a little bit more than 400 to draw the nose. So when we add the nose, it's still going to be a circle. But we definitely don't want it to be as white. So we're going to use a different color for this, but I'm still going to call pygame.draw.circle. Still going to give it surface, and now I know it's passed by reference. So this means that I'm editing this one surface that just keeps getting passed around function to function. I don't want to use the body color though. I want to use the object color. So this is an object that I'm placing on the snow person. And then I'm going to need the center and the radius. And I said the center needs to still have 500 as the x coordinate. I want the y coordinate to be a little bigger because it's going to be below the center. And we can play around with this, but the value I'm going to use is 10 as the radius. And then I can save that. I can type up in the terminal to run it again. And now I can see what happens to snow person. Now it's got a little nose. And now it's just a matter of adding some other facial features. So if we think about the eyes, we have two eyes. One should be to the left and the other one should be to the right. So why don't you think about, and you can tell me, what would be two good sample points? Like what would be two good points in terms of the x and y coordinates that we could assign to draw the eyes? So Claudia's right. One good principle here, I think you mean the x coordinates. Is that the x coordinates should be on either side of 500 by about the same amount, right? So we don't want one eye to be slightly over and then the other one to be way over. That we're just being mean to our snow person. So that's good. We're going to have two calls to circle, and they're both going to use the object color. And I'll just tell you, let's make the eyes a little bigger than the nose. So we're going to make the radius 15 instead of 10. And we need to make the x values symmetric across 500. The values I'm going to pick are going to be 500 plus or minus 60. Play around with these if you like, but I'm going to set 440, and I'm going to set 560. So that's 500 plus 60, and this is 500 minus 60. Then what about the y coordinates? If we're thinking through wherever we put them, we don't want to be mean to the snow person and say the y values are different. That's going to, have eyes up on one side and down on the other. That doesn't seem fair. So we should be above the center. And here's where we say, remember, y is going decreasing as you go up. So if the center of the face is at 400, this number should be lower than 400 and this should be lower than 400. Then we just need to figure out where it needs to be. So yeah, I see some good thoughts. 380. I like that. I'm going to use 360. Not 36,410. That would be bad. 360. But you try 380. Just going to move the eyes down a little bit and get crowded. And I can save this and we can run it. and take a look. Okay, so it's a shy snow person now, but it's starting to fill out. And we just need to give it a mouth. I'm also going to give it some eyebrows. But the mouth is going to be a rectangle. And I'm going to make the mouth red. So it's going to use this accent color. And if we think about a rectangle, I asked you before, what constitutes a circle? And now I'll ask you, what defines a rectangle? What's the minimum amount of information that you need in order to say this object constitutes a rectangle? Some good ideas. In the meantime, I'm going to add a second cough drop. I'm not actually finished with the first one, so this is the cold equivalent of lighting one cigarette using another one that's already in your mouth. But it might be what's necessary to get through this. So some good answers. Some good answers. One answer that I see is width and height. Now, the issue with that is that that doesn't completely define the rectangle because, well, I know how big it is, but I don't know where exactly I need to place it, right? So I could imagine I could move this thing around. So a lot of what I'm getting at with this is, I honestly want to think about, I remember like back in school, there was some exercise that we had about trying to explain something to an alien. And the alien doesn't know, is so different from us that it doesn't know anything about what to do. And then the purpose of the activity was that children are not very good at explaining something completely. And then the teacher would do demonstrations of showing how the alien would misinterpret what somebody was saying. So it's the same sort of thing, at least for now, for a very, very short span in human history. Computers are dumb. AI is getting very smart, but the notion is with programming languages, the programming language is not smart. And you have to very precisely define what you mean. So if you just say width and height, I don't know where to place that. Another good point I saw is you could also just give it 2 points. We'll come back and we might talk about this when we talk about object-oriented programming later. I do want you to imagine if I have 2 points, maybe like opposing corners, I think is what you're thinking. Well, that could represent one rectangle where I just go down and over. But there's also a bunch of rectangles that might be like tilted that could represent. So that actually technically could represent more than one rectangle, and that would not be good. So anytime you have one of these circumstances, we need more information. So we want just enough information to completely encapsulate what constitutes a rectangle, but not too much information. And that's something that we'll see later too. So for now, I think a lot of people said, good to see this, is width and the height. But then you also need one more point. So if I establish a critical point and I set the width and the height, and I also see what about rotating the thing, that's going to be good. Keep that thought in mind. We'll touch on that later when we talk about object-oriented programming. But for now, I'm thinking about an upright rectangle. And so for the upright rectangle, all I need to know is where do I need to start drawing this thing? And if I have the width and the height, I can go down and over and up and across. So we will say a top left corner, which is an X and a Y coordinate, and a width and height. And these are all in pixels, presumably. So this is how the upright rectangle function works in Pygame. It's going to take as input the surface. it's going to take the color. So this is what we've seen before. And then it needs to take the top left corner, the width, and the height. So the function is going to be like pygame.draw.circle, but it's going to be pygame.draw.rect for rectangle. It's going to take the surface, needs to take the color. I want it to be red, so I'm going to give it the accent color, which I've not used yet. And then I want to tell it X and Y, and I'll fill those in. And I need to tell it the width and the height. So if I'm thinking about the mouth, it's going to be wider than it is tall. So a good value for the width is going to be like 140. Good value for the height is going to be 20. And then we're going to have X and Y. So the values that I chose, and we need to be thinking about, what these X and Y values are. Think about what are the important properties that X and Y should have. That's a good question to you. What should X and Y? What should we know about them? Especially compared to what we've already done. Remember, XY is the top left. So if we have our snow person, we're going to put the mouse here. So the top left corner is going to be like right here somewhere. And then it's going to go over and down. So good comment from John. However wide this thing is, if it's 140 pixels wide, that means the top left corner needs to be 70 pixels to the left of center. So that means in this particular case, it's going to be 400 minus 70, which is just 330. Okay. The Y value needs to be a little bit, what did I say? I said 400. I meant to say 500 because the middle X coordinate is 500. We're going to go 70 to the left of that. We also know that it needs to be lower than where the nose is. And remember, the nose was at a Y value of 410. So it's got to be bigger than 410. And the value I'm going to give it is 450. You can play around with that, but I'm going to save it. I'm going to run it. What did I do? Pygame.draw.rect. That says that's invalid. Did I give it the appropriate number of things? I think I did. Here's a little Python annoyance. I think it takes a tuple of 4 things. You might imagine it'd take a tuple of 2 things, the X and the Y, then these other 2 things, but I think it's going to take a tuple of all 4. All right, so that worked. Again, thank you, Python, for the really very clear error report. The direct argument is invalid. Wow, beautiful. All right, so let's look at our snow person. And they're starting to look very happy. And then it's just a matter of let's at least give them a little more texture to the face. And it's going to be an opportunity for me to show you the line function in Pygame. And a line is going to just be, well, now we're going to a simpler part of geometry, and you're saying a line is just connecting 2 points. The other thing we need to know is the thickness of the pen. So I'm going to give it 2 eyebrows. And the 2 eyebrows are going to be going in sort of like a downward direction this way and this way. So they just need to know the starting and the end points. So if I'm going down and to the right, down and to the right means X is going to be increasing and Y is going to be increasing. Okay, and so over here, if I started this way and went this way, I would say X is going to be increasing and Y is going to be decreasing, even though it's going up. So I'll say finally, draw some eyebrows. And we'll make those black as well. So here's pygame.draw. And now we're going to call the line function. and it takes my surface. It takes the color that I'm going to give it, which is, I think I called it object color. And now it needs to take 2 tuples and then the thickness. So the first one I'm going to give it is 42310. So this is to the left of center because it's less than 500. 310 is up pretty high. So this is the left eyebrow. And then I'm going to give it 470. So it's still left of the center line of the face. And 340. So it's going down. So this is the left eyebrow that's going to be going that way. And I need to give it a thickness. So I'll give it a thickness of 10. That's the left eyebrow. I'm going to copy this over. And I'm going to have the right eyebrow, which needs to be right of the center of the face. So the X values, both of them need to be larger than 500. I'm going to have 580. And we're going to be thinking about this as drawing to the left. And so it's going to be 580 to 530. Here we went 420 to 470. Notice, again, symmetry between these two values and these two values, so that makes sense. And the Y values I need to update too. This is going to be the top right corner of the eyebrow, so this is going to be 310, that's fine. And I'm going to leave the 340 here as well, that's okay. So 580, 310, if you think about the face, it's going to be up and to the right. And then 530, 340 is going to be going left and down, because 340 is getting bigger, so the eyebrow is going to go this way. So when we save that and we run it, we're going to finalize our snow person. All right, and they look very, very happy to have been brought to life. Monica, you have a question about, can you draw like a half a circle or something? After this, one of the things I'm going to tell you is, you go and you make whatever you want in Pygame. Post it to our Discord. Go and look at just Google the Pygame documentation. It's going to tell you, here are all the built-in functions you can use. And there's tons of stuff you can have in arcs and all sorts of stuff. I'm showing you everything that we're going to need to produce honestly beautiful representations of cellular automata. We don't need anything other than rectangles and circles. So we're going to get to that soon. I want to finish my snow person for now, so I'll do this a little bit quicker. But I do think it's an opportunity for me to give you an exercise, which is, we've done our draw head function. I can give you an exercise, which is, let's draw the middle. So I'm going to uncomment draw middle, and then I know I need a function that's going to be very similar to this. So down here, I'm just copying this down. We know it needs to take, I'm going to call it draw middle. And it needs to take the surface object. It needs to take the body color. I'm going to draw the middle of the snow person. I'm going to have the object color and the accent color. I'm actually only going to use the first two on my end, but you might have an accent color too. And this is the body. And it's still going to take the same parameters and have the same output. So I need to have this function, and I need to have a draw bottom function too. They're all going to have the same parameters. They're not going to return anything because we're passing by reference. I'm going to say draw the bottom. Let's look at draw middle. You can look at where we placed all this stuff in terms of X and Y values. And you can come back and look at our snow person using those values, knowing that this is 1,000 pixels across and 2,000 pixels tall. And I'll say, allow you to do this as an exercise, which is to write this function, especially if you just start with practicing drawing the circle corresponding to the middle of the snow person. Then you can put some buttons on them or whatever else you'd like to put. Give this a go, and then we'll chat about it shortly. Let me know in the meantime. Feel free to chat. What's your center and radius? So if you have the body, we'll make a big circle. What do you have as the center and the radius? Just so we see if we're kind of on the same page about this, about where it should go. Other thing you might think about is, how about the bottom? What should the center and radius be for the bottom? Claudia says center 500. That's good. Probably all these we don't want it to be off the center of gravity of the snow person. That would be bad. And so the x values for both of these, probably both the middle and the bottom, probably the x coordinate of the center of the circle should be a 500. Good. We also need to go down. Right, so the y-coordinate should be bigger than where it was before at 400. That's another important thing. It looks like there's a thought too, which is, the other thing you might think about is, how big should the radius be? The body should be bigger than the head. So if the head was 180, so we had when we made the head, body should be bigger than that. And the bottom should probably be the biggest of all. So we're able to start to infer what these coordinates, how they should look like, right? And then should they overlap, right? So good question. Should they sit exactly touching, exactly tangential, or should they overlap a bit? Probably if the head is sitting on the body, it's probably going to overlap a little bit because force of gravity. The point is, all of this is like we have to think about math at the end of the day. We can't escape it. All right. So I'm going to write the function. I'm going to think about important things when I make the body. And then I make the bottom. I'm going to make the bottom as well. I'm going to have the same function call that I had when I made the head. So I'm going to have the body color, and it's going to take the surface. The body color is going to be, in this case, white. The x-coordinate should still be 500 because the center of the body shouldn't be different from the center of the head, so it doesn't topple. This value should be bigger than 400. So in this particular case, I need to think about the radius too. The body radius is going to be bigger than 180 because the body needs to be larger than the head. Now this needs to be 260. And we can reason through all of this, and all this makes sense. Then the question is what to make this. And so if this were 260, and before we were at 400, and we had a radius of 180, well, that would take us down to 580. And then if we added 260 to that, I'm not very good at arithmetic, but I think 580 plus 260 is 840. So they would exactly touch if you set that to 840. And I can see what happens. I could save this and run it and look at the snow person, and you'll see you get this exact touching. I don't think that looks very realistic because the head of the snow person's not going to be this like beautiful tangent of circles. It's going to sit down on the body. So to do that, we need to move this body up a bit. And in order to do that, that means that the y-coordinate needs to go, because it's going up, the y-coordinate of the center needs to go down. So I'm going to change this to 800. And I'm going to do the same sort of argument to think about drawing on the bottom. So now I'm going to say, well, I'm going to copy this, and I'm going to draw a circle that says I'm on the surface using the body color. X-coordinate is 500, so it's not getting off kilter. Y-coordinate I'm going to delay. The bottom needs to be the chunkiest part of the snow person. And so I'm going to make it 360. And then for them to touch, well, I would say it would be 800 plus 260, which is the radius of the middle. And then we have the radius of the bottom. So 800 plus 260 is 1060. Then we add another 360 to get to what, 1420? Something like that. So we would set this equal to 1420. Then when I save it and I run it, I want to make sure I uncomment out everything in draw snow person. So I uncomment this. When I run it, we'll see the same thing, which is now we have the tangents again. So I just need to push it up a little bit, and we're nearly there. And when I push it up a little bit, well, I'm going to make the y-coordinate of the center decrease a little bit. I'm going to take it to 1300. And then I'm going to look at my snow person. It looks pretty good. We just need to add a little bit of accent to it. So we could do this in a lot of ways. The thing I'm going to do is I'm just going to give it a few circles as it goes down. So to give it some clothing. And we'll go back to main.py. So this is drawing the bottom. This is drawing the middle. And give it a little character. So I'm going to have a couple more functions that are kind of like the eyes, or the nose, I should say, because they're going to be in the center. And I'm going to have two buttons of sorts going down the middle. Okay, so X is going to be 500. I'm going to set the radius equal to 12. And then the y coordinates are going to be, well, it's going to be slightly above the center here. So I'm going to set 760. And then I'm going to have another one that's a little bit below. So I'm going to take the same function call, and I'm going to make this like 860. And for the bottom, I'm going to add 3 of these things. And I'll have 3 function calls here. The first one, I'm going to have 500 is the x-coordinate, so it's in the center. 12 is the radius, so it's small. And in this value, I'm going to have 1200 to make it a little above the center here. And then I'm going to have one around where the center is. So I'm going to have another, what have I done? I have another one here, and another one here. The middle one I'm going to set at 1320. And I'm going to space them out evenly. So I'm going to say 1200, then 1320, then 1440. I'm going to save it. I'm going to run it. And then I'm going to get my final snow person. Now, one of the things that we might do is maybe you don't like having a snow person with white snow and a red mouth and buttons that are black and eyes and so forth. So we could make it have different attributes if you wanted and change the colors. I could give you the RGB color chart and ask you, what do you think? You know, pick me 3 colors here, and we can just change them. And what I'm doing here is to show you that the colors themselves can be variables that we can, you know, good code or good program is one in which you don't have to make a big change to the underlying parameters. You don't have to change code in a lot of different places, but you can get wildly different behavior. So give me a couple colors that we want to see. I'm open to suggestions, but we need 3, right? We need one for the snow. We need one for the body. We need one for these attributes we're placing on it. And we need a third one for any accent, which I guess in this case is the mouth, but you can play around with this however much you like. Any votes? No yellow snow. That makes me want to do it. So you say 255, 204, and 0. All right, no votes. I'm happy with that. I'm definitely going to do yellow snow. So 255, 204, and 0 is going to be the body. Let's see. Orange for a carrot. We can make its mouth orange, I guess. I like that. So let's do, what did I say we had? 255, 204, and 0. So that's going to be our yellow. And I don't have to replace these. And then we're going to have an orange. Look at the color chart. A good orange would be this one, so it stands out a little bit here. 255, 102, and 0. Well, hopefully it's enough. And this is, I'm preparing you for when we represent an arbitrary cellular automaton, and the thing has like multiple states, and we have 8 different colors. And so we're going to have that in our code when we do this next. All right, let's do pink. This is going to be an ugly snow person, but let's do I don't know if it'll show up well, but for the button color or something, we could do pink. So 255, 153, 204. I can't remember. This is the test of my memory. 153, 204. Okay. And then I'm keeping my black, white, and red, but I'm going to pass in pink for the buttons and the mouth and the face and stuff, or I guess the eyes and the nose. Oh, pink here. And then the body color was going to be our yellow. And instead of red, we're going to do orange. And we can save this and see just how hideous our poor snow person is going to be. Oh, that is really bad. But it's at least mildly Pittsburgh with the black and yellow, so I do like that. And that's about where it stops. But the point is, I didn't have to change my code a whole lot, and I got wildly different behavior. It's about all I want to say about snow people. Except, I would say, for you, change the colors as you like. And the other challenge I would say here is I've assumed that the canvas has to be 1000 by 2000. But if I were to change this to like 2000 and 4000, then the whole thing is going to look weird, because the snow person's not going to be in the center. Right, so it's going to be up here. And so one of the things that you might do is practice, just so that you can play around with graphics, is think about, instead of assuming that the canvas is 1000 by 2000, if these are just arbitrary numbers, and you can access them by, if you have a certain canvas, you can get the width and the height. If you have it in a function, you can access their width and the height. The question is, when you pass it into something like draw ahead, how is it that having an arbitrary width and height would affect this? I'll give you a hint. This should just be half of the width. But how are all of these other numbers going to change? So if you could make it so that you resize the canvas, you resize the snow person in the middle all the time, a bit more algebra, I think, and pattern identification than you might imagine with something like that. But it's a cool challenge to do. The other thing I would say is go through this and do other drawings. So there were some good questions in the chat about, like, what if I want to add certain things to this or draw something different? Go look at the documentation for Pygame. If you make something neat, like, I consider myself a very strong artist, obviously, as a result of this. But if you find something that you feel like is in the same ballpark, post it to Discord. We'd love to see your work. But in the meantime, I want to turn our attention to drawing an automaton. So we've had our fun with the snow, but what we would really like to do is be able to draw an automaton, and specifically we're going to draw the game of life. So the game of life is an automaton in which every cell, it's a grid of cells, every cell is either alive or dead. We want to draw this. In the meantime, I'm going to get another cough drop. Now, to draw the game of life, we want to have a function, and our function is going to be called draw game board or something like that. Okay. More importantly, I want to think about, what are the inputs and what are the outputs of this thing. So we're going to have a function called draw game board. And for the game of life, it's a grid of cells. All those cells are alive or dead. This is the first automaton we're going to work with. If everybody is alive or dead, there's two possibilities. That means that what I'm working with is a board that is a list of bools. So it's a two-dimensional list of booleans. And I can start thinking about what this is going to do. This is going to draw a game board. Say draw a game of life automaton to a, and then we want to think about representing this thing. So actually how I want to represent this is to represent it as a Pygame.surface object. So the parameters here are going to be, well, we have a board, and this is our 2D list of booleans. True equals alive. False equals dead. And there are other things that we care about. So one of the things that we want to know is, like, what should be the color of a cell if it's alive, and what should be the color of a cell if it's dead. If we look at our pentomino, in this case, our alive cells are colored with a dark gray, and our dead cells are colored with white. The other trick we're going to probably apply is that the background cells, so if we make a big board, but a tiny little pattern, everybody on the background is going to assume to be dead. So we basically just set the alive cells of this to begin with. So you need these two things. And there's another thing that we need. It's actually going to be two more things that we need. But for now, I'm going to tell you that we need a cell width parameter as well. The cell width is going to tell me, so I'll just go ahead and start typing out the parameters. So we have a live color, and this is a tuple of RGB values. Those correspond to live cells. And then I'm going to have a dead color too. Everything here is the same. Still a tuple of RGB values corresponding to the dead cells. And then I have a cell width. This is an integer representing the number of pixels, wide and tall, to color, to use, or I should say, just represent a given cell of the game. And then the output is going to be a Pygame.surface. And this is a canvas object corresponding to drawing the board using the given parameters. So for this cell width and for this live color and for this dead color. So now we know that the live color is a tuple of int, int, int. The dead color is a tuple of int, int, int. And the cell width is in pixels, which we know to be an integer too. And so now we've got all of our inputs here. We've specified them out with a doc string. And you see how that doesn't really take too long? mean, if I were writing this for the first time, it's a nice way of just thinking through what it is that I want to do, is to write out all this stuff. Except I've got one more thing that I need to do, of course. I need to say that what we return at the end is a Pygame.surface object. That's important. So that's our canvas. And I probably should perform some tests. So I want to make sure, for example, that our cell width parameter is indeed an integer, or if the cell width parameter, so if it's not an integer, or if the cell width parameter is less than or equal to 0, in either of these cases, I want to raise a value error and say that the cell width parameter has inappropriate type or value. Okay. And I could do, I suppose, the same sort of test for a lot of other things. I could do the colors too. So I could say that we need the board to be a list in general, or I could test that it's a two-dimensional list of bools. The other thing that would be bad would be if the length of the board is equal to 0, because then it doesn't have any rows in it at all. Not a good thing for drawing a board with no rows. And say this. Okay. And I could perform all those tests. It's a good thing to do. In the interest of time, I'm going to just carry on with drawing. So at the start of my function, what we want to do is to say, well, I want to make my surface. So the first thing we do is make the surface. Why? Because I need to set surface equal to something. And then eventually I want to return that thing. And I know how to declare a surface. I set Pygame.surface of width and height. We prepared you for that when we made our snowperson. But then the question is, what should the width and height be? How wide and tall is this thing? What does it depend on? Good, Gal. It depends on the number of... I'm going to assume you didn't mean L's. Number of cells. Good, good, good. All right. So the width is a function of how many cells wide this board is. The height is a function of how many cells tall the Game of Life board is. So far, so good. Also depends on something else. Claudia tells us it needs to depend on the cell width too. So how wide do we want each cell to be represented in pixels? We could use it as 1 pixel. That would be tiny. Each cell is only a tiny point of light. The bigger we make this, the larger the automaton needs to get. So I need to say that the width is equal to the cell width times the height of the board. And the height, what I said, no, the width, sorry, the width is the cell width times the width of the board. Got a little ahead of myself. And the height is the cell width times the height of the board. So we say how many pixels tall is this board? Well, it's how many pixels are associated to each cell times the number of cells. So the question is, how many cells wide is the board? if I give you a two-dimensional list board, how many cells wide would it be? Hint, we can look at our 2D array. Four is true for the specific board that we have. But if I'm taking an arbitrary board, this thing could be huge. It could be 1,000 by 1,000 or 1,000 by 2,000 in terms of cells. The width of the board, I'm thinking horizontally, needs to be a function of how many columns there are in the board. So if we assume that our board is rectangular, more on this later, because it might not be. We might need to check that it's rectangular, which we're going to say for when we work with Game of Life. We look at the length of any row. In particular, if we know that the length of the board is non-zero, so we have at least one row, we just access this board of 0, and that's going to tell us how many columns there are on the board. Similarly, we can say, how many rows are there in the board? Well, it's just the length of the board. That's going to tell us the number of rows. So we'll say width of the board is length of board 0. Height of the board is going to be length of the board. We're actually going to see a better way of doing this next time. But for now, I think that's fine. We'll leave it at that. I can assume that everything here is rectangular, and that's going to be fine. Now we've made our surface. And I've inserted, maybe intentionally, maybe unintentionally, I've inserted an error here where this is not going to work. And here's where you get to remember our little Python weirdness that tells us that pygame.surface takes a tuple instead of just taking 2 ints. I don't know why I would take the tuple, but it means that you have this extra little parentheses. Then we've got our surface. We're eventually going to return it. It's the appropriate number of pixels wide and tall. Sounds like a silly thing, but imagine if you don't get this right, and then you're drawing something on the board, and they're like, well, I don't see the whole pattern. It's like, yeah, because the number of pixels wide and tall was wrong. So we're going to fill the board with the background color, which is dead. And then, so I'm going to say surface.fill of the dead color. And then once I've done that, I want to range over all of the cells and color each one with the appropriate color. And I'll say there's a note here, because the background color is the dead color, I don't need to color the dead cells. So I'll just color only the alive cells. Now I say, well, I've started working with two-dimensional lists. Good thing I know how to range over all of the cells in them. I can say for a row index either I or R or row or something like this. Let's do row and range over the length of the board. Why? Because that's we worked when we introduced two-dimensional lists. We learned this is how you can range over the rows. And then we're going to range for call and range over length of board of 0. You might be thinking, Philip, are you not worried about having a double nesting like this? And I'll say, sometimes I think it's a good thing. And if I'm just ranging over the rows and columns of a two-dimensional list like this, I think it's all right. I'm comfortable with this. So if the cell is alive, draw it. So if board of row call. And you might be comfortable saying equals equals true. Yeah, we don't need that anymore. So we're going to draw a rectangle, which means we have two questions. Where is the top left? What's its width and height? You tell me. BZ says 0, 0. I hope that's not the width and the height. If it's the top left, well, it probably should depend on the row and the column, right? So we need to make sure that that's included too. This is the type of question. This is the type of question that scares people away from programming, because everything that we've done is so straightforward. You just need to get comfortable with writing code like this. Then you have a question like this. I know it's a rectangle. I know it has a width and a height. I know it's top left. Probably top left worries you the most. So what I would say is, when you look at a question like this, there's two ways to approach it. One is to know that the top left is going to involve some formula, and to focus on that first. But remember that we are, first and foremost, we strive to be lazy. And if I'm striving to be lazy, well, I know that the width and the height are both just cell width. That's just the number of pixels wide and tall to draw the rectangle. That's how big the cell is. So if it's 20, hypothetically, we know that the height and width of the cell are both going to be 20. We're just going to draw a square with side length 20. So I know that when I call pygame.draw.rectangle, write out what you know, right? Like, don't focus on the most tricky detail. I know I need to take a surface, and I know this because I can look at my other drawing code that I have, but I'll just tell you, it takes 4 things. It takes the surface, it takes the color, and it's alive, so it needs to take the alive color. Then it needs to take, and I'll show you, when we drew a rectangle, where did we do that? We did that on the head of the snowperson. So it takes the surface, the color as this 3 tuple. Then remember, it takes these 4 weird things, like you think it takes the point as a separate thing from the width and the height, but actually it takes all 4 together as a tuple. So it takes x, y, width, and height. So it takes the top left coordinates, and then it also takes the width and the height, but they're just both cell width. So now we've done the easy part. So what are the top left coordinates? That's the hard part. X is something, and Y is something. And here's where we need to write it down. Look at the pattern, these sorts of things. But it's a function of R. Function of, we think about our X value. It's a function of, maybe not R, probably should be a function of C, or the call. This should be a function of the row. All right, so we can reason through all of that before I even type out what the specific value is here for the question marks. We know that X is going right and left, so it has to depend on the column that we're in. It depends on the column index. Y is going up and down, so it depends on the row index. And here's where we say, well, if R and C are 0 and 0, it's 0 and 0. As you move the column up by 1 each time, this would go up by cell width each time. So you'd start at 0, then it would be cell width, then it would be 2 times the cell width, then 3 times the cell width, and so forth. Oh, because addition's repeated multiplication. As you go down, you would have 0, and then cell width, another cell width, 3 times the cell width, 4 times the cell width, and so on. So in each case, the coordinate of this top left value, so this is 1, 2, 3, 4, 5, times the cell width. If I went to this point, for example, I'd be drawing this, assume that they're squares for a second. I've gone over 3, so it's 3 times the cell width. So 3 times the cell width is the x-coordinate, 5 times the cell width would be the y-coordinate. In general, it's the column index times the cell width is the x-coordinate, and the row index times the cell width is the y-coordinate. So now I can just take that idea, I've expressed it out loud, and then I just have to say, all right, well, x is then equal to the column index that we're at times the cell width, and y is equal to the row index that we're at times the cell width. Pretty good. And why is this tricky? It's tricky because we go back to that point that I made before, which is that your math teacher teaches you Cartesian coordinates, and then now I've had to teach you graphics coordinates, which are reasonable. Top left, go right with x, go down with y, fine. But that's not quite what you have with an array where you think about the row index is first and it goes down, but that's the y coordinate. And then the column is always second, but it goes over, so it's the x coordinate. So you're flipping the y and the x. And if you don't get this right, you're going to be like, well, why is all my patterns are rotated the wrong way? And I'll be honest, the first time I made a game of life, I thought the same thing. I was like, why are my patterns off? I was like, oh, I forgot to just do this conversion of graphics coordinates. All right, so perfectly reasonable thing to have happen. But now we reason through this and understand what we need to do. So we can draw the rectangle. At the end of this, we return the surface, and hey, we're done. Okay, that's our function. The only thing I need to do, right, we set it with the dead color. We know how big it needs to be. We range over the board. For all the live cells, we've set the rectangle, then we return it. It's not that long of a function. The only thing that we need to do is call this function from inside of, let's say, main. So in main, I'm still going to draw my snowperson, but after I draw the snowperson and before I quit Pygame, I think we should run it. So the first thing I want to do is I want to establish what are my colors that I care about for the background or the dead cells, as well as the alive cells. And if you look at our pentomino, what we could do is have the dark cells be alive and the white cells be dead. I think everything winds up just being prettier if we have the background be something like a dark gray, which is why VS Code looks so nice, because everything with this has this nice dark gray background. So I'm going to learn from their design, I'm going to copy it, and I'm going to say, let's look at main, and I'm going to declare a dark gray color to be equal to this tuple, and I'm going to give it 60, 60, 60, 60. As we saw, if all the values are the same, then you're going to be on the grayscale. At 0, 0, 0, you're at black. At 255, 255, 255, you're at white. So a dark gray would be at about 60, 60, 60. I don't need to redeclare white. Okay, so we could redeclare, but it's already been declared. It's already have a white color. It's 255, 255, 255. And then we need to set a cell width too. And I'm going to set it equal to 20. So this is going to make sure that our cells are wide enough for us to really see it. And then we want to declare a pattern. So the game of life pattern that I'm going to declare is, let's look at the pentomino. Okay. And for the pentomino, I've already done this. Here I'm going to remember that in my 2D arrays code, one of the things that I did, I get to use my nice little two-dimensional list declaration like this that I love so much. And I'll just copy over our code from before that created the pentomino. It sets a bunch of values to false, and then it sets 5 values equal to true, corresponding to the values that you see here. So that was our practice with indexing a two-dimensional list. And I'm just going to copy all that code. So We set our number of rows and columns. We create the 5x5 board, and then we set the values that are alive. Now that we have set these, the only thing that there is remaining to do is to say, let's call our function on this board. So if you look at our function, we know that we have a function here that says draw game board. And draw game board is going to take the board, the live color, the dead color, and the cell width, and it's going to return a surface. So I need to know those 4 things. And when I call, I'm going to say, let's call it pentomino surface is equal to draw game board. It's going to take our pentomino. It's going to take the alive color, which is white. It's going to take the dead color, which is this dark gray. And then it needs to take the cell width. So it's got all the parameters that it needs. And now that it's got all these parameters, it can just produce we've drawn the board, and it lives in this pentomino surface canvas object. And then it's just a matter of saving it to file. So I'm going to say pygame.image.save. I'm going to give it pentomino surface. And let's call it rpentomino.png. And that's going to go into our folder. I already have a capital R pentomino. This is going to be the one that we draw. And I can get rid of that later. Okay. So when I do that, then it'll save to file, and Pygame quits, and my code is ready to run. So let's run it. Got this saved. I'm going to hit up, run my code. Oh, it's is instance. I was wondering why I was getting yellow there, but I was just delaying this until it came up as an error message. All right, is instance. There we go. All one word. So we save, we run. And now we're going to take a look at our pentomino. We're going to pray it looks like an R pentomino. It should have the same shape as this. Right? It shouldn't be rotated or anything. And it should be in the middle of the board. So when we look at it, that's what we see. Now the question is, could this be better? And how could we make it better? And I'll give you a free answer of this. One of the things that we might do is, if you want a better image, just in general in graphics, increase cell width so that you're using more pixels, because the width of the board is a function of cell width. So if you have a 5x5 board and the cell width is 100, then multiplying the number of rows by the cell width is going to give you a 500 by 500 board. When we look at it, it's going to be a little more resolved, so this looks a little crisper. That aside, is there anything you might notice, like just graphically, not having anything to do with programming? How is it that we could make our picture prettier? What is it that we might do if we look at this and say, how could this be just a nicer representation of this automaton? Everybody says cell borders, and I love that answer. And that's how I used to draw the automaton. And then I realized that they just wind up when you animate, because any change that you make to this thing, when we animate it over like 1,000 generations, which is what we're going to do because that's when it becomes beautiful, any tiny change you make to the underlying drawing is going to get compounded times 1,000. Drawing lines around the cells seems like such a natural thing to do. After all, that's what you have here. And that looks better. I don't deny it. Some of our patterns on our website, I think, also look like this. And it's the classic way to draw it. I'm going to do something different. I'm going to say, you know what? I can still see these are cells. And I could add dark, thick, black lines against this background. But I don't really need to be able to go in and clearly see that this is cell at row index 100, column index 2000 or whatever in order to appreciate the beauty of it. So I'm not going to do grid lines. If you want grid lines, you know enough to do it. We already have the line function that we used when we drew the snowperson. You could figure out, well, where are these lines going to need to go? I'll give you a hint. If they're going across the entire canvas, we know how wide that would need to be. If they're going across the whole canvas, you know how tall it needs to be. So you just need to figure out, use that information to say it's going like from 0 to something. And so if you have 0 to something on the y coordinates, like it's a vertical line, you just need to know what the x coordinates are. And those are easy. It's just going to be cell width and 2 times cell width and so forth. So we could easily add those. Go and make them. Again, you can always post something like this to Discord, especially after we do the Game of Life implementation and we have an animation of this. And just take a look so that you can see. I'm not going to do it. What I'm going to do is I'm going to take these squares and I'm going to represent them as circles. So it's almost the exact opposite of the snowperson. Oh, our beautiful snowperson, where you want things to overlap in order for it to be a snowperson. In this case, I want them to not touch in order to differentiate the cells. So just from a graphics pretty design perspective, what I'm going to do when I go to main and go into my function for cellular automata, I wish I had not put this at the bottom. So I'm going to just copy it up and put it next to main. But I'm going to put it here. Rather than draw a rectangle, I'm going to draw a circle. And in order to draw this circle, the question is, first off, so this is the old stuff. This is the rectangle. We're going to draw a circle. And where is the center? I'm going to ask very similar questions as before. And what is the radius? So you tell me, where should the center of the circle go? And what should the radius be? And which of those two questions is easier to answer? So if we think about looking at our picture, if I want this to be a circle instead of a square, remember that the side length of the square had cell width pixels. So some good answers there. The radius has to be half of that. The diameter would be cell width of my circle. So the radius has to be cell width divided by 2. So far, so good. So I could do the easy part. I could say that the radius is equal to cell width divided by 2. That's just half of the width of the cell. So far, so good. And then the tricky part becomes, what about x and y? And it's very tempting to just leave them. And honestly, it won't look that bad if you just left them the way that they are. But if you remember the 2D array, that was giving us the top left coordinate of the appropriate cell. And that's where it's like, I don't want to center the circle here, because then if I had something on the boundary of the cell, it would be, you'd only see half of it. You'd get your half moon of the cell. And so that doesn't quite make sense. You want it to be in the center. So then you say, well, if this was my x and y value before, how do I get it to the center? If I go over to cell width by cell width, that's too much. But I could add cell width over 2. And that would get me to the center. A few people got it, good to see. Same thing with the y coordinate. I'm going down, I don't want to add cell width. I want to add cell width divided by 2. All good. So the same type of pattern is there. I just need to add the cell width divided by 2 to each of these things. And then when I represent this, I want to draw a circle and not a rectangle. And I still want to take surface. I still want to take the live color. And now here, when I look at the circle function, when I draw a circle, it takes the center as a 2-tuple, and then it takes the radius separately. So it's a little different from the rectangle, which just takes all of this as 1 tuple. Here it takes the center and then the radius. Thank you, Python. So I need to tell it x comma y is the center, and then the radius is what it is. It's nice because here's another example of like code that's working, that's functioning as we might hope, which is that I've changed the rectangle to a circle, and I'm not going to change that much about the underlying code. I'm just changing a few lines down here where I drew the circle. In fact, you could imagine maybe all this could even be a subroutine, right? And then our code would get even stronger. But for now, I'm going to run this, and I'm going to take a look. And I don't know why that the boundaries on these are not that crisp, because these should be pretty clear-cut circles here. I don't know, maybe I should make it bigger or smaller or something like that. I've gone too far. When I set my cell width, there it is. I change it to 25 or 50 or something like that. I think that's not going to help anything, but yeah, I need to make it larger. Cell width to 500 is strange because, well, at least we'll see. Okay, this is going to be very resolved. All right, that's better. And now I'd say, to me, this seems like a very minor change. It's a very minor change. But again, it is going to factor out big time when you animate this over many generations. But I look at this and I think, there's one other thing that kind of annoys me just from a design perspective. So how could we make it just a little prettier? What could we do? What could we do? Keeping the circles, of course. Some good ideas. I mean, yeah, we could show the dead cells. Key point is they're all dead. So you can add some cells that are like special dead. And when we do other cellular automata, that actually will kind of matter. Like there are some cells that are dead, and then there's some cells that are just on outside of that. I kind of respect that. So we're going to have, like, I think at one point we'll have a background that's dark gray and then a certain dead cell that's black. We could do that. That makes sense. We could add like a dot. Yeah, sure. I just don't like that they're touching personally. So what I'm going to do is I'm going to say, I don't need this much information. Let's give it a little negative space and separate these cells out. And there's two ways of doing that. One would be to go into the function and say, I guess the radius has to be smaller. And then think about handling it that way. So when I actually set the radius, when I set the radius here, it needs to be smaller. And then I say, well, how much smaller does it need to be? And I'm thinking, really, all it needs to be is, I don't know, like 20% smaller. And that changes depending on the value of cell width. So one of the things I could do, I guess, would be to say that the radius itself is smaller by a factor of 20%. Good coding practice would have you screaming no at something like this, because you never want to add something that could be a parameter just as a hard-coded number somewhere deep in the bowels of your code. That's just rude to someone who's coming and looking at your code, because that's not specified anywhere in the doc string and in any sort of documentation of this. Whereas what I could do is just add a scaling factor. It's a float. I've already got 4 parameters. What's one more? And I'll say I've got a scaling factor. And this is a float representing a multiplier that is multiplied by the radius of the cell when we draw it. Okay, to prevent touching. Okay. And now I've added that in, and I'll change this to just scaling factor. And everything should be good, except in main, I need to make sure that I say that with the cell width, I also have a scaling factor equal to 0.8. Now I can change that if I like, and I can get different results. One more thing, and I think this was what was causing things to be grainy. And somebody noticed it. John, I think you noticed it and I missed it, so I'm sorry. I'm eternally sorry. But when we actually draw something and we call this dot circle, you're now entering a realm where the radius is not an integer. And you want it to be an integer, right? It should be a number of pixels across. If you give it a float, presumably something weird might happen now. And so I'll just say, yeah, okay, if the cell width is 50 or whatever, and I scale it by 80%, or 40 and 8, its cell width is 47, and I scale it by 20% down, and then I get a number that's not an integer, just round it down, okay? So you can do that with int of radius. And you're going to do the same thing with x and y, because technically this could wind up not being an integer. And so let's just nudge them ever so slightly by rounding them so that we get the nearest integer. Now when we save that and we run it one more time, I'm missing a scaling factor. Oh, I didn't give it when I drew the board. I didn't actually give it the final parameter, which is scaling factor. And now I save it and I run it and I look at the R pentomino that I produced. And now the cells are all separated out. And you might say that's scaling factor has separated them too much. Okay, take it to 0.85 or 0.9 or whatever. But now our cells are going to be clearly visible. I think it's pretty. If you like grid lines, go add them. And take a look at what happens when you animate it. And you can post it to our Discord. And I'd like to see them. You can also play around with colors. So again, if it's well-written code, I shouldn't have to change it too much, right? I could say, we're going to be Pittsburgh and make it yellow against total black. And I just changed those two things. And then I'm going to run it and look at it again. And you see the same pattern. So we could turn the colors on and off in different ways as much as we like. You might think it's not a big deal to make sure that we focus on the design at this point in time, but it is. It's going to make a huge difference. And the reason why is when we factor it over a bunch of generations, those tiny little things are all going to add up. So this is not a course that's about design or anything like that, but it's a glimpse at why people care so deeply about it. All right. The idea here is we can draw one board. And one of the things that we've learned about in the class a lot that we're going to see even more is if I can do something one time, I can usually do something n times and just iterate that process. So we're not going to do it right now, but it would be pretty straightforward to just write a function that calls this draw game board some number of generations times and then makes a list of our game boards. We'll do that next time because what we really want that for is to take a list of these game boards and feed it into some code that we're going to pull from a package. And that's going to produce an animated GIF visualizing these generations of the board over time. So we need to be able to write both of those things, call this function n times, and then pass it to something that's going to animate it into a visualization. The third thing we need to do is we need to be able to read a board from a file. When these game boards are going to get big, I'm not going to type them all out manually. What I want to do is just have a file that represents them, and they have hundreds of live cells in them or something. I just want to read that in from a file and say, here's the file name, grab in the board. Now I've got my board and I can work with it. And the fourth thing, which is the most exciting thing, which is what we get to do next time, is to implement the engine for Game of Life. We start with a given board, a two-dimensional list of Boolean values, true and false, representing alive and dead. You need to know how wide to make the cells when you draw it. That's important. And you need to know what the colors are. But you also need to know how many generations you want to run this for. And at the end of the day, even without having the cell width or the colors, we're going to separate out the drawing. I just need to make an engine for the Game of Life that takes the number of generations in the initial board and that produces a list of boards corresponding to all the different steps that we take along the way, all the different snapshots of this cellular automaton from the beginning to the final generation. Then we can take that thing and feed it into our drawing engine and draw each board to its own image or its own canvas, and then take those canvases and animate them and view it over time. So we're closer than you think now that we know how to draw things. We're closer than you think because we know how to work with two-dimensional lists and we know how to draw things. So the next thing is to then just build out Game of Life and put it all together. That's what we'll do next time. I will see you then. In the meantime, as always, make sure you like and subscribe, drop us a comment, and happy coding.